sheet. We're going to be talking about now actually figuring out what that constant is, okay? That's what we're going to be doing today, figuring out how to find the constant in these general equations, okay? So I'll give you a moment to get this down. It's basically an example that's already been worked out, so you can have it as a reference, and then we'll do a few together. All right, so when you have an integral of a function, in this case, I'm just going to use this as an example. It says 2t plus 1 dt. We're going to take, we're going to basically take the antiderivative of that, okay? So we add 1 to the exponent, it becomes 2, and it'll be 1 over 2 t to the second. 1/2 times 2 is 1. The antiderivative of 1 is t, and then of course you have your plus c. That is known as your general solution, okay? Because you have that plus c there. That c can be any particular number. The only time that you're going to be able to figure out what c is if they give you some kind of other piece of information, okay? So now suppose that we're given that for this particle, the position at time t equals 1 is 6. To find c, we're basically going to take that information, we're going to plug in. If t equals 1, then that means that y, or our position, also known as s, equals 6. So all we do is we plug in. And as you see, when we plug in, we'll have 1 squared plus 1 plus c. All of that equals 6. So 6 equals 2 plus c. C is 4. So for this particular situation, our constant is 4. Because it tells us that at time t equals 1, when time is 1, our position is at 6. That's how you go about figuring out what your constant is, okay? So it's a process. Just like finding the equation of a normal line, it's a process. To find the equation of a normal or the tangent line, you find the derivative. You plug in the x value. That gives you your slope. You take the point and you write your equation. To find your more particular solution, to find your constant, you still have to take the antiderivative. You take the values you're given and plug in, and then that'll find your constant. Okay? So let's take a look at this example here. It says if f prime of x equals 3x squared plus 2x and f of 2 equals negative 3, we need to find f of x. Find f of x. It gives us our derivative, and it's asking us to find our original equation. And then on top of that, we have some specific information here, which basically tells us the 2 represents what? X. The negative 3 represents what? Y. Okay, so it's like a point that's on this original function. We're going to use that to help us figure out what the constant is. Okay? So the first thing we need to do to figure out our equation is what? Find the antiderivative, okay? So we need to find the antiderivative of this function that I've underlined here. We got to do it in pieces because we have a sum here. So this first part, we pull out the 3. It's going to be 1/3 x to the 3rd. So remember, we add 1 to the exponent, and then we do 1 over the sum. This part here, 2, 1/2, and then of course our plus c, because right now it's a general equation. When we simplify, 3 times 1/3 is just 1x to the 3rd. 2 times 1/2 is just x squared. And then I have a plus c. Remember, you can always check your integration by doing what? The derivative. And it checks out. After I figure out my general equation, I have to take what I'm given, this point here, and plug in. What am I going to replace f of x with? Negative 3 I'm gonna replace x with 2. And then I solve. Negative 3 equals 2 cubed, which is plus 2 squared. 8 plus 4 is? So C is negative 15. So my equation for my original function is f of x equals x cubed plus x squared minus 15. Questions? So it's a process again. It's an antiderivative, plug in your point, solve for C. Yes?
They always give you
So no, they might not always give you your x and your y. They might give you something. They'll give you something to help you figure out what your constant is. Okay. A couple of things that you do need to be aware of. We know that the tick mark means derivative, and without it means the original. You cannot forget also about like your application problems, like kinetics. When you have position, what's the derivative of position? Say again. Velocity. What's the derivative of velocity? Acceleration. You cannot forget that order because they might give you the velocity equation and then they want you to find position or displacement, which means they want you to find the what? Say it again. The original, okay? So do not let that notation throw you off as well, okay? Let's look at another one. Okay, the curve y equals f of x passes through the point 3230. The gradient of the curve is given by f prime of x equals 1 over the 5th root of x cubed. Okay? Again, we want to find what f of x is. So we have this as our derivative. How can we fix that? Move to the top and very good. Because the root, remember the root always goes down to the bottom of the rational exponent and this brings to the top, you gotta make it a negative, okay? I want everyone to find the antiderivative of this right now. I'll give you 17 seconds. Find the antiderivative of this. 15 seconds, that was more like 30 seconds. 35. Okay, remember, you add 1 to the exponent, and then you do 1 over the sum between those two. Okay, so negative 3/5 plus 1 is 2/5. And you cannot have a fraction within a fraction, so to simplify that, you should have had 5/2 x to the 2/5 plus c. Raise your hand if you got that. Okay, so there it is. There's that antiderivative. So then from here, that is what f of x equals the general equation. To find my constant, what am I going to do? I got to plug my points in. What am I plugging in for f of x? 30. What am I plugging in for x? 32. Now before you try to go and pull out your calculators and everything, this would be a non-calculator question. Okay? This would be a non-calculator question. Because I have to do 32 to the 2/5 power. How'd you get 4? Yes, this part alone can be written as the 5th root of 32 squared. All I did was rewrite it back in this root form. The 5th root of 32 is 2. So then you square it and you get 4. Okay? So 4 times 5/2 plus c equals 30. What's 5/2 times 4? It's going to be what? 10. So 30 equals 10 plus c. What's my constant? 20. So then that means f of x is equal to 5/2 x to the 2/5 plus 20. And there is my specific equation for this particular situation.
How did you know what they were asking?
Because they don't give us any, they just say that if you have f of x, they give you a point and they give you the derivative, nothing else. And so that's the only thing that we don't know in this whole situation is what is f of x. Nicholas? Others? All right. This one says the rate of growth of a population of fish is given by that. I will hold off so you guys have a chance to write it. So it says the rate of growth of a population of fish is given by dp over dt equals 150 square root of t for 0 less than t less than 5 years. The initial population is 200 fish. Find the number of fish at t equals 4 years. Okay? It's a lot of information, but in the end, we're trying to find the number of fish at the end of 4 years. Okay? This dp over dt that they give us, what does that represent? The derivatives, remember, is not only just represented with the prime tick mark, but it's also represented as, dy over dx, dp over dt in this case, because we're talking about population and time. So we have the derivative, we're trying to figure out how many fish there were in 4 years, so that means we need to go back to the original equation here, okay? The only way to figure that out is by knowing, okay, what was the original population function? So, gotta take the antiderivative. How can I rewrite this radical? To the 1/2, okay? So we have to take the antiderivative of that. All right? Take the 150, pull it out. What do we do to the exponent? Add 1. So this becomes 1/2 plus 1, t to the 1/2 plus 1. Let's see. I'm writing too big, I probably won't have enough space. So what's 1/2 plus 1? 3/2. So I have 1 over 3/2. That turns into 2/3. Very good. And when I multiply 150 by 2/3, you can still do this without your calculator. I know you can. It is 100. There's your general equation for your population function. Okay? Questions up to here. We're not done with questions up to here. Okay, so that's what you did yesterday. Now we're going to incorporate what we've been talking about today. This is between 0 and 5 years. The initial population was 200 fish. The initial population, that, okay, I'm hearing a lot of things. I'm hearing that's my constant, that's my y, a lot of things. Initial population of 200 fish. It does tell us that is important. Is that 200 a constant? No, yes, no, okay. For those saying no, why? Those saying yes, why?
Because 200 you would plug in for your y, and then 0 would be the time, so it'd be c equals 200. Because the t would go away, it would be 0.
Right, because initial means what we start out with, which is technically 0. So this information gives us that point that we were looking for to plug in to find our constant. Our time was 0, and our y, our population was 200. Now when I plug in 0 for t, and I plug in 200 for p of t, what happens to this whole first term? It goes away. So in actuality, 200 is our constant, because our initial time was 0, and 0 raised to anything times 100 is still going to give me 0. So 100 t to the 3/2 plus 200 is our equation for our population, and then to figure out how many fish there are in 4 years, you do what? Plug in 4 for t. So P of 4 equals 100 for 3/2 plus 200. Don't need your calculator to do this. 4 to the 3/2 is what? It's 8. Okay? Because it's the square root of 4 cubed. 4 cubed is 64, square root of that is 8, or the square root of 4 is 2. So after 4 years, how many fish are there? 1,000. Okay? So let's recap. It's asking us to find our number of fish after 4 years. Well, in order to do that, we need to know what our original population function is, because we're going to plug in 4 for t. So we have to find the antiderivative, which was P of t, 100 t to the 3/2 plus c. And then to find the actual equation, we need to take the fact that the initial population was 200. And then plug in that point to get our constant. Then we had our general equation, which is down here, the last line in the blue. And then we plugged in 4 to figure out exactly how many fish there were after 4 years. Are there any questions of finding your equation, your original equation?